আচ্ছা আচ্ছা V belt is discussed or not? I have forgotten. V belt.
স্যার এর আগের স্লাইড গুলো যদি একটু দেখাতেন তাহলে বুঝতে পারতাম আর কি। হ্যাঁ স্যার, এর আগে পর্যন্ত হয়েছিল। হ্যাঁ 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 স্যার, এই স্লাইডটা হয়েছিল। আই থিঙ্ক ভি বেলটা স্টার্ট হবে মনে হয় এবারে।
Okay. So we start V belt. What is V belt? It is already discussed. This is the cross section of V belt, and an elemental section is considered. Now the analysis. The analysis is like this. Now forces. This is the elemental section. This is the V belt. The included V angle is theta. So this is the normal force dn by 2, dn by 2. This is theta by 2. This is theta by 2. So the for the elemental section, look at the elemental section. This is mu dn. You consider the elemental section. Okay. For the elemental section, the angle is d phi, and this is d phi by 2, d phi by 2. On this side p, on this side p plus dp, on this side p plus dp. So this is tight side, this is slack side, and this is mu dn. Now this is the centrifugal force, and this is the normal force. Okay, now the force components p plus dp. This is the centrifugal force. Now for comparing with the flat belt, the difference lies in the normal reaction that arises on the two sides of V belt. The normal reaction here, two sides, and in case of flat belt, normal reaction was here, but in case of V belt, normal reaction is here. This is not, this surface is not, this surface is free. It is not in contact, this surface. So this surface is in contact. So normal reaction that arises on the two sides of V belt, and it is assumed equal on each side, that is dn by 2. The resultant reaction dn sine theta by 2, this one dn sine theta by 2, normal reaction. The frictional force is mu dn. This should be remain unchanged, and the equilibrium of forces in x and y direction. So you look at this elemental section. So p plus dp cos d phi by 2 equal to p cos d phi by 2 plus mu dn. Okay, and in other direction, p plus dp sine d phi by 2 plus p sine d phi by 2 plus mv squared d phi plus dn sine theta by 2. So equation number 9 and equation number 10. Now this should be phi, not theta. This should be phi, not theta. So as phi is small, so substituting sine d phi by 2 equal to d phi by 2 and cos d phi by 2 equal to 1 in equation 9, then dn will be equal to dp by mu. Now this dn equal to dp by mu, equation number 11. Now substituting equation number 11 in equation number 10, and neglecting second order differential, that means multiplication of d phi. we get this equation, dp by p minus mv square divided by equal to mu d phi. Just manipulation, we will get this. Now we have to integrate the above. When angle of contact of belt varies from 0 to alpha, angle of contact, then and tension on belt P1 to P2. So after integrating, it will be P1 minus mv square divided by P2 minus mv square equal to e to the power mu alpha divided by sin theta by 2. Now in case of flat belt, the equation was P1 minus mv square divided by P2 minus mv square equal to e to the power mu alpha. So this was the equation. Now for V belt, the equation changes to in this form. Okay, so this is the effective one. We will discuss this. Now this P1 by P2 in V belt, the usual design criteria is to get P1 by P2 equal to 5. This is the design criteria. Now comparing the tension equations of flat belt and V belt. So this thing comes. So mu alpha divided by sin theta by 2. So the effective coefficient of friction in case of V belt is much higher than that of flat belt for identical combination of materials due to the term life. So due to this term, obviously the effective coefficient of friction is higher, because this is smaller than 1, sin theta by 2 is smaller than 1. So obviously this value will be higher. Okay, so effective coefficient of friction becomes mu by sin theta by 2. Mu by sin theta by 2 is the effective coefficient of friction. Now power capacity. Power capacity for every thing is Kw equal to P1 minus P2 into V by 1000. Now for V belt, the power transmission capacity will be obviously higher because slip will be lower. Due to this, slip will be lower, and P1 minus P2 is being the effective pull. So P1 is the on tension side, P2 is on slack side. So P1 minus P2 is the effective pull, and that effective pull is responsible for transmission of power. So this is the equation for transmission of power. Now condition for maximum power. Condition for maximum power, this is derived for flat belt. Now say you just try to follow these 3 sentences. Pi is the initial tension. That means before start, the belt should be wrapped over 2 pulleys. So there must be some initial tension. So Pi is the initial tension for transmission of power. For keeping the length of belt constant, now length of belt will remain constant. This should remain constant. So for keeping the belt remaining constant, and elasticity, linear elasticity coefficient, elongation on tight side is equal to the contraction on the loose side. So there will be on the tight side it is being pulled, and on the slack side it is being pushed. Okay, so on the tight side it will be elongated, and on the slack side it will be contracted. And assuming this thing, that means length of belt remains constant, and the elongation of the tight side, and there is contraction on the loose side, and they should be equal to keep the belt constant, and considering the linear elastic coefficient. So this will be the equation. So P1 minus Pi equal to Pi minus P2, and from this Pi is equal to half into P1 plus P2. Can you accept this thing, this part? P1 minus Pi equal to Pi minus P2. Considering this statement, you will accept this thing? Will you accept? Anyone respond? Hello? Can you listen to me?
Yes, sir. Yes, sir.
So this thing is accepted by you. And from this, P1 is equal to this. Now, belt tension is this. For flat belt tension is this, P1 minus mv square divided by P2 minus mv square equal to e to the power mu alpha. And this thing, by manipulation, we can write this. Then we can write this. We can write this. And from this, putting equation 1 into equation 2, and after manipulation, we will get. That means we are trying to, the condition for maximum power, we like to deduce the condition for maximum power. So power will be equal to P1 minus Pt into V. V is the velocity, linear velocity. So power is P1 minus P2 into V. And from this equation we can write, that means here there is P1 minus P2 term. So getting this P1 minus P2 term multiplied by V, we can write this expression. So P1 minus P2 into V will be equal to this. Now differentiate. That means del V power equal to 0. And from this is constant. This is constant. So del V P1V minus mv cube equal to 0. And from this, V is equal to Pi divided by 3m. That is the velocity for maximum power. So this is the optimum velocity for maximum power transmission. So there are so many step jumps for this is for note purpose. This is a note, and you will study in the book. There is a detailed direction. So you will accept that this is the optimum velocity for maximum power transmission. Do you accept this? Hello?
Yes, sir. Yes.
Okay. So this is the optimum velocity for maximum power transmission. Okay. Now, how to select belt? What we do for belt and pulley drive? What we do? You have to select belt. That means belts are available in the market, and there are different manufacturers. So manufacturers table are there, and the catalog are there. So from the manufacturer's catalog, according to the necessity of the user, they have to select belt. That means by design, what we actually do by design, we design a thing and we then give it to the workshop for a particular industrial unit. What they do, they design one thing and they give it to the workshop, and they manufacture it. So this is the thing. But in case of belt, the belt is to be selected. So the market availability is there, and you cannot manufacture a belt, but you have to select according to the necessity. And for that, there is catalog of the manufacturer. And here the Dunlop Rubber, they manufacture belt, and their catalog is to be consulted. So how to consult this? This is very important, and you try to follow it step by step. There are so many things. There are so many important things and factors. Now, first of all, designing a belt drive requires the following information: power and speed of the drive unit, So power speed of drive unit, speed of the driven unit. These are the requirement. For this you have to design. Desired center distance, that means center to center distance, driver pulley and driven pulley. And service condition, under what service condition it is working. So these are the minimum things that should be known for designing a drive. Now you then try to follow it step by step. For maximum power, a load correction factor is needed. So this is the load, this is the power. You have to multiply it by load correction factor. Okay, then this is kW max. There will be other kW terms. You remember that this is kW max, and this kW max is obtained by using a load correction factor, and there is manufacturer table for load correction factor. So this is for normal load, this is for steady load, this is for intermittent load, and this is for shock load. For shock load, this is high. So there is kW, you multiply it by FA, get the value of FA from the table of load correction factor, and you get a value of kW max. So remember, you have obtained a kW max. Now, power transmission capacity is developed for 180 degree arc of contact. So where we get 180 degree arc of contact? If the two pulleys are of equal length, equal diameter, then we get 180 degree arc of contact. But normally, the two pulleys are not of equal diameter. So they are of different diameter. That means there must be elevation of speed on the driven side or lowering of the speed on the driven side. Accordingly, you have to select whether the pulley on the driven side should be higher. The diameter of the pulley on the driven side should be higher or lower than the diameter of the driver side. So according to the necessity. So power transmission capacity is developed for 180 degree arc of contact. Now, if arc of contact is less, so obviously belt tension will be higher. If the arc of contact is less, belt tension will be higher, e to the power mu alpha. So if alpha is lower, then for the same power transmission, that means to get the same value of P1 minus P2, the P1 should be higher. So less the arc of contact, higher will be the belt tension. So an arc of contact factor is used to counter it. So you have to use an arc of contact factor if the arc of contact is other than 180 degree. Now table for arc of contact, FD. So for 120 degree 1.33 and for 200 degree 0.94. So these are the angle. That means the S for shorter pulley. So we can get the value of FD from this table. Now come to another point, another important point. Power rating or load rating is a term. Power rating or load rating is a term used for specifying power transmitting capacity of flat belts expressed as. That means power transmitting capacity of flat belt is expressed as, this term is important. You see how the term is there. Per millimeter width of the belt, per ply at 180 degree arc of contact. Now per millimeter width means belt width. Now part ply, what is the meaning of part ply? Part ply means you consider the flat belt. So there is one layer of the flat belt. There may be another layer overlapping. There may be another layer overlapping. So if one layer is overlapped, it is for 2 ply. If another layer is there, then it is for 3 ply. Okay, so that means if the number of ply is higher, obviously power rating will be higher. So the expression is per millimeter wide. That means if the width of the belt is higher, then obviously power rating will be higher. So it is expressed in this term, unit term. Unit term is in this way: per millimeter width per ply at 180-degree arc of contact. So it is based on 180-degree arc of contact. Okay. Now for Dunlop belt, there are two types of power transmitting capacity. One is called high speed, one is called port. Now for high speed, it is, that means this power rating capacity is this value, kilowatt per millimeter width per ply, and it is on the basis of 180-degree. This is based on arc of contact of 180-degree of and belt velocity of 5.08 meter per second. This term is also important. These are all from Dunlop. Okay, so this is based on arc of contact of 180-degree and belt velocity of 5.08 meter per second. So these terms, if remember, there is 180-degree, there is 5.08, and there are, from the table, there are two types of belt. One is high speed, where this is the power rating capacity, and another is called port, where this is the power rating capacity. So this table you remember, there is a table like this, you remember this. Now preferred cast iron and MS pulley diameter, these are the preferred diameter. So these are available in the market. So pulleys are also available in the market, and the manufacturers sell it in the market, and the dimensions of the pulleys are normally this, from 40 to 2000 it is written there. So this is the standard diameter of the pulley which are available in the market. Okay, these are the preferred diameter. Now selection of flat belt, how to select the flat belt. So there is diameters, and you have to select the diameters from this. That means you have to select the pulleys from these diameters. You should not go from this table. You should not go away from the table. Now you see standard belt width. For 3 ply, these are the standard belt width. For 4 ply, these are the standard belt width. For 5 ply, standard belt width. For 6 ply, these are the standard belt width. So these are available in the market. Okay. Now for Dunlop belts, optimum velocity ranges between 17.8 to 22.9 meter per second. So these are the optimum velocity range. These should be allowed. That means when you use Dunlop belt, for other company there is another. So when you use Dunlop belt, the optimum velocity, that is the surface velocity, should be in between this 17.8 to 22.9 meter per second. Now I am telling you the steps how to select the flat belt. Steps to follow. First step, from the available ranges of velocities, that means 17.8 to 22.9 meter per second, a value is adopted according to the need. That means there is one need, that is your need. According to the need, you select a velocity, and from that you calculate the small d. Now from the speed ratio, that is a speed ratio. So from the speed ratio, you find the capital D. Okay, from the speed ratio, you find the capital D. So can you follow the first sentence? There is meter per second and D is calculated. Can you follow?
Yes, sir.
Okay, so D, small d is calculated. Then from the speed ratio, you calculate the capital D. Now these capital D and small d should be selected from the standard pulley diameters as nearest preferred value. Accordingly, so you calculate a D. Okay, you take my point. You have calculated small d, then you have calculated capital D. But this capital D and small d, you have to select it from the diameter table. So from the diameter table, when you consult the diameter table, this capital D and small d, whatever you have calculated, you have to change that. That means it should be according to the table value, according to the diameters which are tabled. Okay, so you have to change the capital D and small d. So when you change the capital D and small d, this meter per second will be changed. So accordingly, you modify the belt velocities and check the values to keep within the range of optimum value. So you change the velocities, but you have to change there is a stipulation, that means this should be within this range. Okay, so accordingly modify and check that it is within this range. Now the second point is, there is kW. According to the service condition, you select the load correction factor and get the kW max. So multiply FA and kW, then you get a kW max. Now the angle of wrap of smaller pulley. So angle of wrap is 180 degree minus twice sin inverse capital D minus small d by 2c. So this is your angle of wrap. Okay. Now find the corrected power. So there is a kW max. Then you use this FD. And get the corrected value of kW. What is this FD? What is this FD? That is table for arc of contact. This FD is coming from arc of contact. Okay. So when you get this value of alpha, then you have to get from this value of alpha, you will get a value of FD and multiply FD with kW max, then you get a kW corrected value. So this is the corrected value of kW. Now corrected power rating. So what should be the power rating? Hello.
Sir, why the 2-ply, 3-ply is used?
For strengthening the belt. If it is 2-ply, it is stronger than 1-ply. If it is 3-ply, it will be stronger than 3-ply. It is stronger than the 2-ply or 1-ply. Okay, just for strengthening the belt. Okay.
Okay, sir. Sir, in last one slide, I saw that the lesser the arc of contact, more will be the higher tension. So, could you please explain this point again?
Which one?
Sir, the previous one, I think. No, sir, the previous one. Yes, sir. Here. Yes, sir. Here. The less the arc of contact, higher will be the belt tension.
Oh, P1 by P2 is equal to e to the power mu alpha.
Yes,
okay?
Sir.
Alpha is the angle of contact. Okay. Alpha is the angle of contact.
Okay, sir.
Clear? Now, if you for the same power transmission, that means P1 minus P2 should be the same. Okay. So P1 minus P2 is responsible for the transmission of power. Okay. Now, if alpha is lower, then that means arc of contact is lower. Alpha is lower means arc of contact is lower. So if alpha is lower, arc of contact is lower, then P1 by P2 is e to the power mu alpha. So P1 should be made higher. That means it should be the P1 should be made higher. That is the question. Belt tension will be higher to keep P1 minus P2 same. Can you get my point?
Yes, sir, বলছি
yes,
পরের স্লাইডটা একবার যাবেন স্যার?
হ্যাঁ যাবো, আগে এই সাইডটা হয়ে যাক, পরের সাইডে যাবো।
হ্যাঁ
এই সাইডটা হয়েছে, এটা বুঝতে পেরেছো?
হ্যাঁ স্যার, ক্লিয়ার স্যার।
আচ্ছা।
এর পরেরটা স্যার, এখানে বলছেন স্যার ইনিশিয়ালি আমরা স্যার ভেলোসিটিটা কনসিডার করছি, তার রেসপেক্টে স্মল ডি ক্যাপিটাল ডিটা বার করলো, তো তারপরে স্যার আবার তাহলে ক্যাপিটাল ডি আর স্মল ডিটাকে কনসিডার কেন করবো?
এই ক্যাপিটাল ডি স্মল ডি তুমি একটা ক্যালকুলেটেড ভ্যালু, this calculated value may not be the same as available in the table, preferred table. Suppose where is the preferred table? This is the preferred table. Suppose you have calculated 38. So what you should do? Considering the speed, you have calculated 38, but you have to make it 40. So whenever you make it 40, then speed will change. Clear? You have a speed range, and on the basis of speed range you calculate a value of d, and that value say say it is other than 40, say it is 38 or 42, whatever it may be. Okay, so you have to make it 40. So whenever you make it 40, then that speed will change. So you get the speed and check whether that speed lies within the range. Clear? Do you get my point?
Yes sir, yes.
Speed should be within this range. This is the optimum velocities. Now this is very important. So this thing, that means kW corrected, you have considered alpha. So by considering alpha, you have got a value of kW corrected. Okay, so this kW corrected is now at your hand. Now go to this thing, high speed kW. This is the expression for high speed. High speed means a type of belt. So kW corrected dating means this is on the basis of 5.08 meter per second velocity. Okay, so you have to divide it by 5.08, then multiply it by v. You go to this table. You look at the table. This is for 0.118. So say for high speed, this is for 0.0118 for 5.08 meter per second and 180 degree arc of contact. So 180 degree arc of contact, there must be a factor for if it is other than 180 degree, and there must be a factor for if the velocity is other than 5.08. Okay, then come here. You come here. So it is 0.0118. This is for 5.08. So you divide it by 5.08 and multiply by v, whatever your speed is there. It is clear? You divide it by 5.08 and then multiply it by v. Okay, similarly for 4, the expression is 0.0147. You divide it by 5.08 and multiply by v. Okay, is it clear? You first of all tell me if this is clear, then I will go to the next step. Is there anyone in the class? Or you have
Yes
left?
sir, yes sir.
Yes, sir.
Can you sir please repeat this part?
Huh? That means
এই পার্টটা আরেকবার
you just remember the table. Remember the table. That means it is for high speed, it is 0.0118. It is written there. And also it is written there that it is based on 5.08 meter per second. But your speed is other than 5.08. Okay? So you divide it by 5.08 and multiply your V. Okay? Similarly, for 4, you divide it by 5.08 and multiply it by V. Okay? Is it clear?
Okay.
So KW corrected rating is now obtained. Okay. Now white multiplied by number of plies. How it comes? How it comes? White multiplied by number of plies. How it comes? You see. You again go to the table. What is written there? There is 0.18. There is KW. There is divided by millimeter wide. There is divided by ply. Okay. So millimeter wide and ply, these are there. Okay. Kilowatt. So kilowatt rating, millimeter, kilowatt by millimeter wide by ply. Okay. Now you come here. So KW corrected divided by KW corrected rating. If you divide these two, then you will get white multiplied by number of plies. This is the total value and this is the rating. Rating means unit. Okay. So if you divide the total by the unit, then you will get the unit. The unit is white multiplied by number of plies. Do you get my point? Hello?
Yes, sir. Yes, sir.
So white multiplied by number of plies is this. Calculate the belt width assuming suitable number of plies. So you assume how far you will go. You select 1 ply or 2 ply or 3 ply, what is available there at your hand. At your workshop, what is available there. If it is 2 ply, you use 2 here. If it is 3 ply, you use 3 here. Then accordingly find out the width. Okay. Now find out the belt length. So is it clear? Is it now clear?
Yes, sir. Yes, sir. Yes, sir.
So we can find out the belt length this way. Okay. So let us stop here.
Okay.
Okay, sir.
Okay, sir. Thank you.
স্যার বলছি স্যার ফ্রিকশন ক্লাচ আর স্যার বেল্টের নোটস গুলো কি স্যার আমাদের
কোনটা পাঠাই
share করা হয়নি এখনো।
কোনটা পাঠানো? বেল্ট এখনো শেষ হয়নি, বেল্ট
ওই-
শেষ হলে পাঠাবো।
ওয়েল্ডিং ও পাঠানো হয়নি।
ওয়েল্ডিংটা পাঠাইনি? ওয়েল্ডিং আর ফ্রিকশন ক্লাচ এই দুটো পাঠানো হয়নি, তাই তো? আচ্ছা ঠিক আছে, আমি পাঠিয়ে দেবো। ঠিক আছে। ওকে, থ্যাংক ইউ।
থ্যাংক ইউ স্যার।
Okay. Thank you.
Thank you, sir.